All right, so we have a data sheet in front of us today, and it forces a pretty wild question.
Okay.
Is any single computer cable ever worth $596?
It is a jarring number. I mean, for something most of us think of as, a commodity that just comes free in the box.
Exactly. So we're looking at the Kramer CLS-AOCDP-UF-197. And our mission for this deep dive is to figure out why on earth this DisplayPort cable costs as much as a new game console.
Right, and what problem it solves that a cheap $20 one just can't.
To start, I guess you have to look at the length. 60 meters?
Yeah, that's
Yeah,
the key. This isn't for your desk. That's almost 200 feet.
Which brings us to a physics problem.
Yeah.
So if I take a normal copper DisplayPort cable and I try to run it, say, 200 feet across a warehouse,
Yeah.
what actually happens to the signal?
You run into what engineers call the digital cliff.
The digital cliff.
Yeah. It's not like old analog signals, which would just get a little fuzzy or, filled with static.
Sure, a bit snowy.
Right. With digital, it's all or nothing. The electrical resistance over that much copper just eats away at the signal. The ones and zeros, they don't arrive. You don't get a bad picture.
You get nothing.
You get a black screen. The signal falls right off a cliff.
Okay, so how does this Kramer cable bridge that gap? The specs call it an active optical cable, an AOC.
And that's the secret sauce. It's a hybrid design. If you were to strip this cable open, which at this price, please don't,
No, thank you.
you'd find 4 tiny strands of multi-mode optical fiber, but also 8 copper wires.
So it's using light.
Exactly. It converts the electrical video signal into pulses of light, shoots it down the glass fiber, and then converts it back to electricity at the other end.
Because light doesn't really face resistance over that kind of distance.
It has almost zero signal loss or attenuation. That's how they can guarantee a bandwidth of 32.4 gigabits per second.
Which is enough for, what, 8K?
Full 8K resolution at 60 hertz, totally uncompressed. And that's not just video, it's also carrying up to 8 channels of uncompressed PCM audio down that same little strand of glass.
That is a massive amount of data.
But wait, you said it has copper wires in there too. Why, if the fiber is doing all the heavy lifting for the data, why is copper still involved?
That's a great question, and it all comes down to power. Fiber is glass. It can't carry electricity.
So you need to power the little chips that do the converting at each end.
Right. And usually with these active cables, you see a little USB cable hanging off the end that you have to plug into a wall adapter.
Oh, I've seen those. They're a pain.
A total nightmare for installers. Imagine trying to find a power outlet in a ceiling crawl space or behind a stadium jumbotron.
Not gonna happen.
So Kramer uses those copper strands to pull a tiny amount of power less than half a watt directly from the DisplayPort source itself.
So it's completely self-powered. Plug and play.
You got it. It looks and acts like a normal cable, but inside it's this incredibly sophisticated optical transceiver. That makes sense. Now, looking at the build, it's clearly for commercial installs.
Yeah.
Medical imaging, control rooms. But I saw this acronym in the safety specs. LSHF. Low smoke and halogen-free. Why is the plastic jacket such a big deal?
This is critical for public buildings. Most standard cables use a PVC jacket. If PVC catches fire, it releases chlorine gas.
Which is not good.
No, it effectively turns into hydrochloric acid in your lungs. In a fire, the toxic smoke from cabling can be more dangerous than the fire itself.
Wow.
So LSHF materials, they don't release those toxic halogens. It's about meeting really strict safety codes, EN standards in Europe, FCC here. You have a liability to worry about.
So you're paying for the physics of getting 8K across a football field, but you're also paying for professional grade safety and compliance.
And durability. The specs say it can handle 25 kilograms of pulling strength. You can snake it through conduit without snapping the fibers inside.
It really changes how you think about a computer setup.
It does.
Because if I could just put my hot, noisy workstation in a server closet 200 feet away and run one of these to my desk.
You get perfect, uncompromised performance with absolutely zero noise and zero heat at your workspace.
And that kind of leads us to a final thought for you to chew on. We've spent, 40 years tethered to within a few feet of our computer towers.
Right, pretty much.
With active optical tech like this becoming more standardized, are we finally seeing the death of the desktop computer as a physical object that has to sit on your desk?
And it's certainly starting to look that way. The machine and the interface are becoming 2 very separate things.
Thanks for listening to this deep dive. Check the show notes for a link to the datasheet, and we'll catch you on the next one.